So this section is about invertibility. So we already talked about inverse functions a little bit earlier in the semester, and we're going to dive a little deeper this time. So before we talk about invertibility, I want us to recall what the definition of a function is. So remember that f of t, q equals f of t, is a function, means that for every input t, there is exactly one corresponding output q. So what this looks like on our graph, let me use this color. For each value of t, I can input t and get out exactly one value of q. So I can give you an input and you tell me exactly one output, okay? Now, if additionally I can do the opposite, so if I can give you an output q, and no matter what that output is, it corresponds to exactly one input t, then we say f of t is invertible. So looking at this graph here, if I give you a value of q, and I say, when is this output achieved? There is only, at least in the part of the graph I've drawn, there is only one value t that corresponds to. So I'm looking at this particular output, and there's a unique input that it corresponds to. Okay, so to be a function meant that I passed the vertical line test. Over every input was exactly one output. Now, for it to be invertible, it additionally has to pass a horizontal line test. For every output, it needs to correspond to exactly one input, which means a horizontal line can only intersect my graph exactly once, and that will give me the corresponding input. So let's see what would it look like for a function to not be invertible. So this is a new function, let's call this g of t. In this case, I do have a function. It passes the vertical line test. For any value of t, there's exactly one corresponding output. But now if I gave you an output value, say I wanted to know when does g of t equal 0, if I look at the output 0, that corresponds to two different input values. So this function is not invertible. It does not pass the horizontal line test. I have several horizontal lines here that cross this graph more than once. Okay, another way to think of this is if you turned yourself sideways, it wouldn't pass the vertical line test. One more piece of notation I want to introduce here is when I have an invertible function, I have a new function called f inverse. I indicate it with a little -1, which is confusing because I don't mean a negative exponent here, okay? So when I write f inverse does not mean the same as 1 over f. So caution. But I have a new function called f inverse whose inputs are q and whose outputs are t. Okay, and so in this case, I can't make q my inputs because I would have more than one output for an input. Here, I could make q my inputs because my original function passes the horizontal line test, or in other words, because for every output, there is exactly one corresponding input.